Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 9th, 2025, about 6 days ago. The striking result is that this paper cuts unsafe responses on wild jailbreak from 39.0% to 4.6%, while also slashing overrefusals on or bench from 45.3% to 9.9%. The paper is titled The Alignment Waltz, Jointly Training Agents to Collaborate for Safety. And as we'll see later, the implications for model training are quite significant. In short, a multi-agent reinforcement learning setup called WaltzRL pairs a conversation agent with a feedback agent, using a dynamic improvement reward, engages only when needed, and preserves general capabilities. Alright, the introduction stressed the safety-helpfulness tension. Figure 1 presents how WaltzRL addresses it. The left panel shows the inference protocol, where a conversation agent drafts an initial reply and a feedback agent labels unsafe or overrefuse, provides reasoning, and gives feedback so the conversation agent revises the response. The example converts attack code into safe historical context. The right panel outlines training. A collaborative rollout generates samples. Rewards are computed separately using the dynamic improvement reward, and both agents update in parallel. Figure 1 laid out the pipeline. Table 1 now reports outcomes. The table shows that WaltzRL cuts attack success on wild jailbreak from 39 to 4.6, and drops over refusal on or bench from 45 to 9.9, which shifts the average to the best trade-off. The scatter plot places method 7 at the bottom left, so both unsafe outputs and refusals fall together. Safeguards alone raise refusals, while single model reinforcement learning helps less because it lacks targeted feedback. So while Table 1 highlighted the safety trade-off gains, Table 3 details how the feedback agent behaves in practice. The table shows much higher label accuracy on wild jailbreak, jumping from about 31 to 70%, and strong accuracy on or bench. Feedback triggering rate drops sharply, from about 82 to 48% on wild jailbreak, and 76 to 43% on or bench, which means fewer interventions and lower latency during inference. So while Table 3 showed how feedback fired less often, Figure 2 examines which reward design trains the feedback agent best. The left panel shows higher improvement rates for setups B and C than setup A. The middle panel shows worsened rates stay very low for all three, which means feedback rarely harms the reply. The right panel shows label accuracy highest for setup A, moderate for setup B, and lowest for setup C, so conditioning the dynamic improvement reward on correct labels preserves accuracy. Well, Figure 2 compared reward designs. Table 5 tests the two-stage recipe directly. The table shows that removing stage 2 raises attack success on wild jailbreak from about 4.6 to 11.7 and boosts over refuse on or bench from about 9.9 to 35, which signals a large safety drop. Label accuracy stays roughly similar across settings. Feedback trigger rates also remain comparable, so the gains mainly come from better collaborative training. So the big takeaways are clear. A collaborative multi-agent reinforcement learning setup with a dynamic improvement reward slashes unsafe outputs and overrefusals, while keeping general skills intact. Adaptive feedback engages only when needed, which preserves latency and usability. The broader implication is deployable safety that is both precise and helpful. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.